Hi, right, let's try putting this actually into practice then. So we've given it some numbers. So what might happen is you would have a triangle which either has this symbol in the bottom, so this sort of square symbol in the bottom, which basically says that it's a 90 degrees, so therefore you know it's a right angled triangle, or it will tell you in the question that it's a right angled triangle. And what would happen is you might have the two shorter sides and they ask you, well, what's the long side worth? Well, let's think about what we've just looked at in the introduction. The introduction says that basically this side squared add this side squared is equal to this side squared. So what I'm going to do is I'm going to do 3 squared, which is 9, because 3 times 3 is 9. I'm going to do 4 times 4, or 4 squared, which is 16. So now we have the two areas of these squares that we were drawing on to the ends of our triangle. And so we add them together. So if I do 16 add 9, well, that equals 25. So now I know that if this was centimetres, these are 9 centimetres squared. This area here would be 16 centimetres squared, and this one here would be 25 centimetres squared. So what would just the side length be then? Well, what squared gives you 25? 5. Because root 25 is 5. Okay, so the square root of 25 is 5. So now we know that this side is 3, this side is 4, and this side is 5. Okay, let's put it into practice with the actual formula, because you may have realised that I've said a few times already that this side add this side equals this side. And you might have noticed that when I was saying that, I was saying that this side squared and this side squared added together gives me this side squared. So what we say is the two shorter sides added together is equal to the longer side squared. We need a general formula. And the general formula we use is A, B, and C. Okay, so A squared plus B squared is equal to C squared. That's Pythagoras' formula. That's it. Okay, A and B are the shorter sides. It doesn't matter which, they are transferable. You can switch them around, it's not a problem. The only one that's fixed is the long side. Now the long side, the hypotenuse, is the C. Okay, this is C, always. So let's try another quick example. So if I were to just quickly roughly draw out this shape here. So this is a right angled triangle, I'm told that, and it's 6 by 8, a 6 here and an 8 here. What I'm going to do is I'm just going to randomly assign A and B to this. So I'm going to say A, B. That's it. Now I'm going to assign C. C has to be the hypotenuse, so this one is C, and we want to find out what C is. So what I'm going to do is I'm going to substitute the numbers. Now substituting into the formula is just like substitution on a football field. You take that defender off and you replace him with another defender. Okay, so what I'm going to do is I'm going to take this A off and I'm going to replace it with this 6. So 6 squared plus substituting the B for the 8 for the B, 8 squared equals C squared. So now what I'm going to do is I'm going to do the numbers squared. So 6 squared is 36. 8 squared is 64, which equals C squared. Now when I add those two together, I end up with 100. So what I now know is that C squared is equal to 100. So the final step is work out what just C on its own is. So we can do square rooting at this stage. So C equals the square root of 100. And you know that the square root of 100 is 10. Okay, and that's it. If you want to try it out, if you want to practice it, or you just want to test it to see whether it's true, draw yourself two lines at 90 degrees to each other, which are 3 and 4 in length, and then measure what the other one is. Now, there will be a slight inaccuracy if you're drawing it, so you would expect to be around about 5, but mathematically it works perfectly. And that's it. Okay, so if this triangle is 6 and 8, this one must be 10. If this one's 3 and 4, this one must be 5. Okay, the next video I'll do is when these numbers are a bit harder, because obviously they're not all nice numbers, nice whole numbers, nice integer values. Sometimes they work out to be decimals. Sometimes the side lengths could even be decimals as well. And we'll just have an investigate of how to deal with those. Okay, good luck.